All right, guys. Good morning. Welcome to the second session on the College Cloud. We're going to be covering the first part of the voltage session today. So before you guys actually do the session and listen to this with me, be sure to watch the YouTube video, which is above the PowerPoints on your College Cloud. Obviously, the video titled Voltage will give you a really good introduction to what voltage is and so on. All right. So today with me, we're just going to be going through the PowerPoint. All right. I'm going to take you with it. We'll do it step by step, and it should cover everything you need to answer the associated questions in your assessment. All right. You should be able to see my my shared screen, which we've got the PowerPoint going there. Session 2, voltage. All right. So in this session today, guys, we're going to be doing the following. We're going to be covering point 1, explain what voltage is using an example. We're going to be doing point 2, understand the term potential difference. These 2 points are pretty much identical. It's just terminology there that we're going to understand. And it's the third one there down in this session that we're going to cover. All right, these second 3 are part of the second session for this topic. When we talk about theory in electrics, there's a lot of theory involved. The theory is always aiming to give you the knowledge to complete a practical task. All right, so points 1 and 2 will help you achieve point 3, which is understand how to measure voltage, which meter we use, and the units it's measured in. In the previous session, when we talked about current, we talked about measuring current with an ammeter and how it was connected in the circuit. We'll be understanding today how if you try and measure voltage in the same way as you measure current, you're in for a pretty dangerous situation there. All right, so we definitely don't want to do that. So those 3 bullet points there, you guys can take a note of those 3, because the idea behind the session with me now is that by the end of it, you'll be able to answer those 3 things. All right. Okay, so what is voltage? Definitions of voltage is the electrical pressure and occurs between 2 points if one point has more or less electrons than another. So I'm going to do some pretty average drawings to help you. Okay, so if we have an example of a car battery, like I said, I'm not the best drawer, especially when it's on something like this. If we have our 2 terminals there, we have our positive and we have our negative. All right. Basically, what we have is the following dots that I'm going to draw are electrons. The slides will also cover this as well. All right. So if one of them is an electron, then this side here has a lot. All right. You've got a load of electrons on one side compared to less electrons on the other side. All right. Now, if you've got more on one side, so let's double check to our definition in red. Anything in red, guys, okay? I want you to write down so we've got it and always can go back to it. Electrical pressure occurs between 2 points. All right, so these are our 2 points. If I had a voltmeter here, which I can draw there, okay, and that would be our V for voltmeter. Then our leads coming off our voltmeter would be your, excuse me, your red lead would be coming off and will go there, and your black lead would be coming off and go into there. All right. So what a voltmeter does, and if it was a car battery, you would read something along the lines of that: 12 volts. All right, 12 volts DC, because it provides current in one direction. All right, because the pressure doesn't change, the difference doesn't change. It's always more on this side compared to that side. All right, so If you have more electrons on one side than the other, that's called a difference, all right? And this is what we want to understand with voltage. The voltage is always the difference from one place to another, the difference in electrons, all right? And the way the circuit works from this point, all right, is if I was to connect a conductor, all right, I'll draw it through the right, and hopefully you guys, that's not too much of an issue, trying to do it like that. If I was to draw a big thick conductor like that, all right, something like that, okay? So if that's a cable, obviously there would be some sort of load in the middle so we don't have a short circuit, all right? But the electrons which are here, because this side is very strongly negative and the electrons are negative, two like forces there, this is going to push away the electrons there. And because it pushes away, the electrons then travel around the circuit by creating a pressure. Okay. Think of it another way. If you had, if I was to delete some of these to the point where I've got the same number on either side, then there is no difference now. There can't be any more push from there because this side is providing the same amount. You've got 6 there, 6 there. You've got equal amount of pressure either side, so nothing can flow. Okay, you can think of that another way. If I was to, once again, try and draw something that looks like, we're not going to have a load this time. But if I was to draw something like this, and this is just a tube with air in it, okay? Now, if I provide or blow into the tube this way with pressure the same size as that, which is maybe, I don't know, 10 psi, we'll just call it 10 for now. If there's 0 down the bottom, then we're going to have air flowing in this direction all the way through and out the other side in one direction if I continue to have the pressure here. All right, so this is the same as what a battery does. Okay, it's providing pressure and pushing the flow through in one direction because you've got more pressure on one side compared to the other. Now if I was to put another 1 there, now we've got the equal amount of pressure in the top and the bottom, which means you can't possibly get any flow inside because they're fighting against each other and they cancel each other out. Okay, now then, the more electrons we have on one side compared to the other, or the higher this number becomes up here compared to this one, the bigger the difference, the bigger the pressure, and in our speak, this one here will be bigger airflow. In ours, it's more voltage, and more voltage will then make more current flow. Okay. If we were to do this in the sense of an electrical circuit, I draw that out for you here, then we've got our battery on this side. I've got my negative conductor coming across over here. Remember, in an electrical circuit, we have to have some sort of load. All right, I'll just draw or attempt to draw the resistor symbol there. Okay, that'll do there. And I'll do my positive conductor coming back to the battery. Okay. All right, so linking this back to what I just talked about with the pressure in the air pipe. Remember that the big side of the battery is your plus, and the bottom side is my minus. Okay, So there's more electrons on one side to the other, so there's going to be pressure flowing, all right? Now, the way I want you guys to try and remember it, easy to remember, is that our red is where the pressure is, okay? So however much pressure, in our case here, we'll say maybe, I don't know, there's 12 volts of electrical pressure. All right, we've always got to then say that the black, which is a negative, is then, we've got to say 0 pressure, okay, which would then 0 volts. Oops, excuse me, 0 volts, okay. Now, if you were to get a voltmeter and connect the voltmeter, I don't want to do it in red. I connect my voltmeter like this, and there it is with a V. And again, I use my colored leads and I connect across the battery. You have to connect across, okay? You have to measure the difference from one side to the other. It's called measuring it in parallel, all right? Red goes to red, black goes to black, because we're measuring the difference. When we talked about current last time, we make sure the current flows through the tester. So the ammeter would go in this area here. It would go on there. Oops, excuse me. Okay, so the current's got to go through it. So if you notice, your red cable would go to the red, and your black cable would also go to the red. So this is connected in series. We talked about that last time. So the current would travel through there. It would go through your meter, out of your meter, and back through the red. Okay, so that's obviously what we talked about last time with current. This time we don't want that to happen. All right? We want to measure the difference from one side to the other. We've talked about the pressure on the red compared to the black. So it's 12 to 0. The difference between 12 and 0, 12 minus 0 is 12. All right, so that's what we would measure there. Now you may be able to see from this that if I follow this point round from there all the way across to this other side, this is the same conductor. So this is essentially the same cable, the same point. And if I was to test, I'll put another voltmeter in the circuit there. And then I'll have the leads coming out. So my black one will go to black, remember? And the red one will go to the top. By looking at it like that, it's an identical reading you'll get there. It's 12 volts again, because you're looking at the difference between one side of the load to the other. And the load, it's very important to remember that on this side, we've got a battery which provides the pressure. That's what it does, all right? It provides the pressure by creating this difference. We'll look at what that difference is called in a second. But it's also very important to remember that if we have 0 down the bottom and 12 at the top, the battery has provided this 12 of pressure up there, and it's gone now by the time we get to the bottom. So it's extremely important to say that the load of the circuit is what uses pressure. How much of it does it use? The loads in the circuit will always use all of the pressure, okay? That's the rule. It has to. There can't be 3 volts on the black, because that is not right, okay? It has to, your black has to be your 0 reference, and then any pressure that is created is always on the red. All right, I don't want to draw too much on this page, guys. I've gone into quite a lot of detail, but if you remember from what I talked about with AC and DC last week, this is obviously your DC. I showed you the graph, all right, and we had a line there, and our line there was 0 volts, or just 0 reference, all right. When we had our line there for our DC, we had this straight line, okay, and we talked about the current traveling in this direction, okay. So basically what we've got, if I was to draw in the remaining part of the graph to link it to the circuit below is that the current travels along the red. So this side is where our load would be, and this side is where the battery would be. That's essentially the same thing, linking it down to the bottom. Okay, so it's really important when we're talking about a voltage is electrical pressure. We're talking about something that can provide that for us. We've got a battery, and the battery has a positive and a negative, as we all know. And those 2 points have a different number of electrons. If they have the same, if your mobile phone, for example, is fully charged, then at 100%, then the difference of electrons is at its maximum. As throughout the day, your phone is losing its charge, and it's losing its number of electrons until it's eventually flat. A flat battery is a battery with no difference, all right, because it can't provide any pressure anymore, can't provide the current flow anymore. All right. Like I said, guys, there's quite a lot of information in electrics. Okay, I'm hoping these sessions are going to help you guys out. Also, watch the video, but Ken and I will be available for any questions you do have as well. Okay. Excuse me. All right, so just going in, we've gone into quite a lot of detail to what I wanted to cover. All right, so now we're going to look at some of the things that are going to visually help us. All right, so we've got examples of voltage. Okay, so examples of pressure, really, that I should say there. And we've got two there. We've got electrical pressure on the right-hand side, which is our battery. I've just gone through that. It's a better picture than my drawing. But again, we've got a battery, and we've got a positive, and we've got a negative terminal. Now, as you guys know, the one on the right-hand side is going to be the one with all the electrons, like that. And then this one, a positive, is going to have less electrons. Okay. This side is going to repel these minuses, and it's going to repel them this direction. Okay. And then if we put something in the way here, something like a load, then if it's a light bulb, then that will work there. That is probably the worst drawing you'll see on any training video. Hopefully the explanation has gone with it, right? But yeah, that's what a battery is. How it works, all right? You've got a load of electrons on one side, less on the other. That is a difference, okay? Now, when you're measuring voltage, we are measuring this difference. The bigger the difference, or the bigger the difference in electrons from one side to the other, the bigger the voltage, okay? At the moment, I could be measuring 12 volts there. If I was to increase this number by a lot, as you get the idea, it may go up to 30 volts, 50 volts, and so on, okay? As the battery is running out, the voltage is going to get less and less and less until we've got a flat battery when both sides are equal, all right? The one on the left-hand side is talking about a water pump. Water is used by electrical trainers to explain electricity, because unfortunately we can't see electric moving and flowing and stuff like that, right? But we can with water. So a water pump provides the pressure. That pressure will push the water through the pipe. Now, the water through the pipe is the same as the current through a conductor, but the current won't flow if there's no battery. The water won't flow if there's no pressure to push it. Okay. All right. Okay, so this is showing, it's a better image of what I was trying to draw earlier, all right, with my dots. Like you can see, your negative side of your voltage source, so this voltage source would be a battery again. There's more electrons from one side to the other. Now, we call that the technical term, and it's a really important one to remember, all right? This underlined up here is your potential difference, okay? So your potential difference is what voltage is, all right? Potential difference is measured in volts. Should be a capital. Okay. Now the important thing to realize, guys, all right, is that if you're measuring, I'm assuming everyone has been in the workshop so far, all right? If you've been in the workshop so far, you may have worked on some of the lights, all right? So you'll have 4 terminals in there, okay? Now this is why we're teaching you this theory, okay? And then at the bottom, it's kind of tight for me to draw it in, but I'll try my best. At the bottom, you'll have your switch, okay? Now your switch there is going to have your common there, and just for now, I'm just going to draw the other one, which is a number 1. All right? So I'm going to just try and draw. That would be a C. That would be number 1. And then at the top, we'd have our loop. And then these two are unmarked, and this is where our active would go. And neutral. Remember, these terms are for AC. And then we'd have our earth up there. All right. So I'm not going to worry about the earth for now. I don't want to overcomplicate this. But with our neutral, guys, it would come from the switchboard, and it would go into there. All right. And then basically, if you've got, it's not easy for me to draw. Right? If we've got the light bulb in the circuit there, from the point that I've just drawn the neutral, all right, it would be connected there. And, excuse me, and from the active, that would go to the light bulb as well. All right, so that would then power that, and it would be light. Okay, so why am I talking about this? Well, from the switchboard as well, we would need to have a red cable. The red cable would come along, and it would go into this connector block, which is called a loop. Okay, out of the connector block, it will come down, and it will go into there, and it will come out of there because this is the switch. I'm trying to draw it as tidy as I can. And then that then will link up in this block. Okay, so just to draw the current flow through this circuit, all right, it's going to come through here into this connector block, down the cable, into the common. All right, the common is a switch. Let's assume this switch is on, like that. It's going to then go through the switch, up there, through there, which is our switch wire, and then to there, where it comes, it switches the light on, and then it has its return there through the 0, all the way back. All right, and that's a closed circuit, okay? Now it's important to remember, guys, that we said that the load, which is up here, is what uses the pressure. Okay, it uses the pressure, it uses the voltage. It doesn't mean, though, that there's no current on the black. All right, the current in the black, if this is 1 amp, is going to be the same in the red. So there's always the same amount of current in both cables. All right, the reason why you can't get a shock from a black, unless there's a fault, so don't touch one, is because there's no pressure there, because the load has used the pressure up. Okay, but why have I shown you this drawing? Okay, because watch. If I was to get you guys to measure voltage, okay, if I wanted to measure the voltage in this circuit and I wasn't sure what I was doing, if I came down the bottom, okay, now the light is on at the moment. I've got my voltage tester. This is the thing, all right, this is, let's say, a 230 volt circuit. This is the issue, okay, that you're gonna have. If I know that this circuit is on, if I put my black lead in number 1, and then I put my red lead in there, we know that this circuit is switched on. We know the light is on. An untrained person would expect to see the voltage in the circuit here. But the dangerous thing is you're going to see 0 at that point. All right. Why am I going to see 0? Okay, and I'm going to draw another one in before I tell you the answer there. Let's get rid of that. Let's get it in black. So I've got 2 voltmeters going on. I've got that one there. All right. I've got voltage at the top. So let's have a look this time. Let's correctly connect it into where I can measure the voltage. So, and excuse the lines crossing each other, but from this point here is where I'm going to put my black lead. All right, so the black lead goes into the neutral, and the red lead needs to go in to either of these points. All right, but let's say for now, this point here. Okay, now because this is the important part at the top, we want to look at a potential difference, in electrons from one point to the other. Now, the tester at the bottom is measuring look at the electrons flowing through. There's no difference between this point here and this point here because the current going through there is identical. All right, but from this point here and this point here where we've got our other tester leads, notice that we have something in the way which uses pressure. That means that this is going to use the pressure that's in the circuit. So you're going to have a difference. Going in, you're going to have your 230. And this is going to use all of that. And then at the bottom here, you're going to have nothing. 230 take away 0 is then where our correct term is how we measured it. It's there. All right. Extremely important to understand that when we're measuring voltage, we're measuring the difference from one side to the other. All right, you can measure a live part of a circuit. Excuse me. You can still try and measure voltage on a circuit which you can see is switched on, and you can get 0. All right. As another important thing to note when you're measuring voltage, guys, is on the scale you're going to have voltage AC, and you're also going to have voltage DC. All right. Now, if I put voltage DC to measure up here, this is an AC circuit. The voltage DC is going to say 0 because there is no voltage DC up there. All right. Same thing. If I try and measure a battery with voltage AC, it's going to say 0 because there's no voltage AC coming out of a battery. All right. We talked about that in our last session, the symbols for AC and DC. So if it was volts AC, it'll show that on the tester. If it's volts DC, it'll show that on the tester. All right, we've got to make sure we put the tester on the right scale, but even more importantly, we've got to understand the theory behind it so we know what we're testing. Okay, just make sure, guys, we remember that the difference is what we're measuring. Okay, the difference from one side to the other. All right. Okay, let's clear the screen and we can move on from there. Okay, so the top line there, guys, is something that you should take note of here. So is this? Let's go back. You can take note of this. All right, the larger the difference in electrons between the negative and the positive, the larger the voltage would be. Now, we've just talked about that a few times. I drew it a few times. But again, all right, it's okay listening to me say it. It's always important to write it down as well so you can refer back to it. All right. You guys have all of these PowerPoints to access. So you obviously got the time to watch the video, pause the video. But if you do need to go back to them, you can go back and look on your student site as well. The difference in electrons from one side to the other will be the bigger the voltage. The bigger the voltage, the bigger the pressure, the more current that will flow. This is shown here with two what are supposed to be clouds. All right, you've got two clouds which have rubbed against each other. The friction has caused one of the clouds to build up a lot of electrons compared to the other one. If there's a lot of electrons in one cloud compared to the other one, we've got a difference from one to the other, a potential difference. More electrons one place to the other is a difference, and that's a voltage. Okay, now the difference from cloud to cloud there, and even from cloud to ground, the negative one is going to be the one which wants to get rid of those extra electrons it's built up. So it'll either then send them down to the ground in lightning, which is the flow of the electrons, which you can call current. It'll either strike the ground or it will strike the cloud which has less electrons to balance itself out. Once that's happened, both clouds are then equally charged and nothing can flow between them. All right. One of those clouds will then have to develop more electrons by friction and rubbing against another one again, and then that's why you get multiple lightning strikes. And again, lots and lots of voltage there, millions of volts there. All right, same principle, but this now is a AA battery. You can see on the AA that the positive is at the top, negative is at the bottom. All right, so even if you guys do know this, all right, when you're measuring voltage with a simple battery like this, remember that we're measuring the difference from one side to the other. Now, to get our polarity correct, which is our plus and minus, our black lead goes to the negative, and our red lead will go to the top. And our tester here will show 1.5 volts of potential difference if it's a brand new healthy battery. Okay, now it may seem like a silly thing to do, but if I was to draw my cable there because I don't know what I'm doing, I'm going to get the same amount of whatever on both sides, the same number of electrons. The difference between there to there is 0, and it's going to say 0 on my tester. Right? Anyone who would do that obviously doesn't know what they're doing. Okay. Sometimes it's obvious to read the voltage of a battery, and suddenly when you open up an AC circuit, when you guys come to do that in the future, suddenly there's a lot of cables there, a lot of reds, a lot of greens, a lot of blacks. Suddenly it's very confusing. Right? So we need to be able to understand that we're measuring from one point to the other. If you measure from one red to another red, you're going to see 0, okay, because there's no difference there. Stupidly dangerous stuff. Okay. All right, so in red, guys, is the stuff that you always need to write down, okay? Voltage is measured in volts, should be a capital. The symbol for voltage is V, all right? When we talk about voltage measured, this is the units, okay? Units, and I've talked about that before when we talked about Ohm's law. V is the symbol, and it's also the units for voltage, so it's an easy one to remember. Symbol voltage volt is V. The voltage from a voltage source, such as a battery, is also called its electromotive force, EMF. EMF is something that you may or may not have heard of. It's not something that you need to worry about too much at this stage. The further you get into electrics, whether it be Cert 3 or Cert 4, however far you guys want to go, you'll start to lose voltage in a sense of talking about it in a practical sense, like a battery. They'll talk about EMF, but EMF is measured in volts. Okay, so as long as you've got that down in red, that's all good. Okay, as I said, you can pause the video. I'm going to skip this page. All right, so measuring voltage. Okay, the tester and the symbol in a circuit that we would use is here. Okay, so I'll just draw a circle around that. So that's the thing we need to take note of. Okay, now last week it was the same circle with an A, that was the ammeter. This week it's the voltmeter. Okay, now we've got 3 examples of voltmeters there. Okay, now recommending brands is something that I think that we should do for you guys so you don't waste your money. On the right hand side we have a Fluke tester, which is an excellent tester brand. Okay, they are expensive, but again, you get what you pay for, and these things save your life. All right, now another thing just to take note of, guys, all right, is that if you look at your analog tester on your left hand side, we're going to ignore the middle one, all right, and we're going to look at the one on the right hand side. Now again, the one on the right hand side is an excellent tester. I've got the same tester myself, but for someone who's inexperienced and not sure what they're doing, you can see that we mentioned the same thing with current last week, is if I just dot, we've got voltage AC, we've got hertz, which is frequency, we've got voltage DC, we've got millivolts DC, we've got ohms, we've got our beeper, which is resistance, but it beeps. Then we've got current there, AC and DC, okay? Now, to measure a 12 volt battery, I have to have it on the one it's on there now, right? So it's pointing to your volts DC range. Okay, but also, and I don't know if you guys can see this, it can be quite hard to see, but at the bottom we've got 4 ports. All right, the ones on the left hand side are for current. This one which if you zoom in you can see it says COM, that one will always have the black coming out of it because it's the common one, we use it for everything. Whereas if I want to measure voltage, you can see there's a V, so that's where the red one would need to be if I'm measuring voltage. Okay, if I'm measuring current, the red one would need to be over this side. All right, now we talked about in our last session that, and I'll tell you why that is, okay, and why it can be dangerous if we don't understand that. All right, always try to link our theory back to our practical. When we're measuring, I'm just going to have a look at the next slide to see what. Okay, that does it for me. All right, so connecting a voltmeter, okay, you can see this one on the screen there is measuring the difference from the red to the black. Remember, the black is it's got no pressure because the load has used it up, and the battery is providing the pressure along the positive. All right, so it shows there in this tester that the voltage is 12 volts. All right, this is what it looks like on the left hand side practically. On the right hand side, they've drawn the circuit with the correct symbols, and obviously they've got their voltmeter there. And notice that I'm just going to draw the correct color cable so you guys can see that it would be red to black, and this would be the red lead. As you can see, it goes to the positive of the tester. Right. Now then, last week when we had the ammeter had to have a very low resistance. What we mean by that is that we wanted all the current in the circuit to flow through it. So all the current can flow through easily. All right, that's what we want the ammeter to do. We want it to be able to be connected in the circuit and the circuit doesn't notice. The current flows through, and that's what we want, okay? If the ammeter had a high resistance, then nothing could flow through it, then we wouldn't be able to test the circuit. All right, well, with a voltmeter must have a very high resistance. We're measuring voltage, we're measuring the difference from one side to the other. We don't want any current to flow through our tester, all right? Because any current that does is going to affect the reading we get, all right? Must have a very high resistance to stop current flowing through it, so it can measure the difference. All right, hopefully that makes sense, okay? We don't want, if I was to, I've just drawn that there for you now, if I was to get rid of these bits, all right, I'm measuring the voltage across this lamp, which according to the circuit on the left-hand side is going to be 12, all right? If I have it connected now, I don't want the current to flow through here, to flow through my switch, and I don't want it to get to this point and then some go down here and some go down here. Because any current that goes through my voltmeter is going to make the amount that goes through my lamp less, and the lamp will be dimmer, and the reading in the circuit there will not be correct. All right, so ideally what we want is for it to look like that, but with those bits back. So the current in the circuit goes through, we test the voltage, our voltmeter will read 12 volts, and then it doesn't interrupt the circuit. The circuit doesn't know it's being tested because of the high resistance of this. The high resistance stops anything going through it, so we can measure the circuit easy. Okay. Right. That's how we connect the voltmeter across the supply, right? Because we're measuring the difference. All right, so now we're going to have a quick look at the types of voltmeter. Okay, this is what we call a proximity tester. Proximity means proximity tester, or volt stick, or whatever other terms are used for it. We wouldn't usually use the word proximity tester on site. But what it means is it works when it's close to the cable. All right, it picks up an electric field which is produced from the voltage. So the closer you get to the voltage, this one particular on the screen will just light up on the end to show the electric field actually lights up the light bulb that's inside. So that's basically how it works, right? You press it against a live cable and it'll show you whether there is power there or not. Now we need to take note of the pros and cons of these things, all right? I think everyone should have one of these anyway for the pros, because we don't, excuse me, need to cut or break into a cable to test it. All right, think of a voltmeter that we talked about earlier. We've got to be able to press it on the red and the black to measure the difference. Well, if I'm crawling through a roof space and I've just got cables lying all over the place, I'm not going to be able to do that. All right, I want to be able to pick a cable up and I want to be able to test it without cutting it. All right, so this is why these things are good, is you can press it against the tester and it will light up if it's voltage in there, or it will obviously stay off if there's nothing there. Okay, there are cons though with these, okay, and they can be quite dangerous. First off, the cons is that it will pick up voltage from near. All right, like I just said, if you've got 5 cables lying on the floor, you can't just press it against one of them, because if the one you're pressing against is dead but the one next to it is live, this thing will still light up. So it's very dangerous and confusing in that sense. All right, ideally you would pick the cable up and press it against there. All right, so it'll pick up voltage from nearby cables. So from an accuracy point of view, you're not always sure if it's picking the right one up. And secondly, and this is in your assessment when we're talking about lots of different types of voltmeter. So a few examples are your volt stick, your solenoid tester, your neon tester. They all will either light up or will make a noise when they sense voltage. They all have the same con in that they don't show the amount of voltage present. So obviously, excuse me guys. So obviously with a voltmeter, a digital display, you'd be able to see if it's 230 volts or 12 volts or something like that. These just tell you if it's there or not. Okay, they don't tell you how much there is. So that is obviously quite a big negative side to that. Okay. Okay, that's our volt stick done. If you guys need any more information, obviously you can Google these testers. Fluke, again, excellent. Milwaukee actually do a really good one too. All right, so you can look up them, see what they do, and ask us questions afterwards. Other types of voltmeter. Excuse me. You've got your plug-in tester. All right, guys. Now I wouldn't recommend necessarily getting one of these. What this thing will do is what we call the polarity check on it as well. So when you plug it into a power point, it will light up, and these are the colors here depending on which order, if the house has been wired correctly or the power point's been wired correctly. All right, so if you've got your 3 lights, if it's a sequence of blue, green, and then off, then that's correct. The ones underneath here, if you plug it in, it shows here that all of these are fault conditions. All right. Personally, guys, this is not the type of thing that I'd like to carry. But there are, like I said, I'll do a positive and negative for these two. The pros for these is that they light up, and usually they buzz. All right, which is good if you're working on your own, because you can listen to it switch on and off if you haven't got someone there to know if the supply is going on and off. Okay. Once again, the cons doesn't show the reading. Excuse me. Yeah, it's only really good for that one thing. All right. So the light up and buzz, if you're working on your own, you can hear whether the PowerPoint's going off and on. And then obviously the cons, it doesn't show that up there. Okay, move on. All right, so this is your multimeter. So there is a type of tester that isn't included in this PowerPoint. All right, guys, and that's the one really that I would suggest if you guys are looking at buying testers you get, and that's your LED type of tester. All right. In your voltage video from YouTube, the guy explaining that video talks about the types of testers he suggests getting, and I agree with the choices he says there. I don't have them in here, but again, an LED is a good one, all right, because it relies on the power from the supply to light it up, as opposed to the one you're looking at on my screen, which the battery shows you the reading. All right, so you got your multimeter. So like I said, the multimeter, and a good make. The pros, it can complete multiple tests. So it's not just voltage DC, you can do pretty much everything. It shows accurate measurements. So, excuse me. All right, so for example, it may show 239.5 volts. All right, that would be an accurate measurement that the type of meter can use. There will be more pros and cons than I'm just listing, guys. I'm just giving you a few because I know your assessment will ask for them, plus the major ones. All right, so the cons, the biggest con with these, all right, is that if you have the meter on the wrong scale, it will give you an incorrect reading, which is obviously dangerous if you're trying to measure 230 volts AC on the DC range, which is on the screen. It's going to say 0. All right, there's going to be 230 volts of live voltage there, and it's going to read 0. So it's incredibly dangerous from that point of view. Other cons as well is the biggest one I find that students have an issue with when they're testing in class is the ports at the bottom of the tester need to be correct for the tester to measure the desired value. Like I said, guys, if you've got if you want to use this as an ammeter, it'll have a very low resistance. If you try and use it as a voltmeter, it'll have a very high resistance if you mix up which one you're using. And I'll write it over here, okay? Using a multimeter to measure voltage on the current setting. Remember, we're connecting this across the supply from red to black. Now, if a multimeter, an ammeter has a very low resistance, that means all the current in the circuit will go through your tester. All right. Using a multimeter to measure voltage on the current setting means you are creating. Sorry about the typing. Creating a short circuit which will damage the tester and could cause injury. It's a bit complicated to explain in a session like this, all right? So that's something that Ken and I will go on about afterwards. Again, using the opposite now, using a multimeter to measure current. On the voltage setting. Remember that the current has to try and flow through the tester. Well, a voltage meter has a massive resistance. So that means that no current will be able to flow through the tester. So no reading can be taken. All right, so the voltmeter will basically act like an open switch and the circuit will just not work. All right. Okay, let's clear all that. We can move on. All right, so producing a voltage, guys, okay, as this is part of the next session. So what I want you guys to do is I want you to look at producing a voltage by these things, all right? So with mechanical, you can look at things like generators. With electrical, you can look at things, with chemical, you can look at things like batteries. These are all good for the assessment, right, guys? With heat, we look at thermocouples. So a quick Google search to these 4 things and how they work. And with light energy, we look at photovoltaic panels, or as you know them, solar panels. They produce voltage from light particles. All right, so a quick Google search to how they work as well. I'm just going to add in, all right, so generators, guys, spinning a magnet to create voltage is what they do. All right, have a look up there, but also have a look at these as well. Okay, it's much better if you guys actually Google this and find it out yourself than listen to Ken and I talking about them, because there's a lot of theory that goes into this stuff, whereas really you just need to know how it works. All right, these crystals here, guys, when you put pressure on them, they create a voltage. All right, you guys have all got them in your house. I'll give you a clue, so when you're looking through them, you'll know if you're looking in the right place. If you press down on a crystal, it will click. Maybe click a few times, and that spark that it produces used to light something else. All right, so have a look into that to see if you can find that out. Okay, what I just want to finish off with is I'll go back. I'll just do it here. No, in fact, I'll leave the next part for the next session. All right. I'm going to stop the recording there. If you guys have any questions, all right, make sure you get in touch with the college, whether via email or calling or anything like that, however you feel most comfortable messaging us. What I've gone through today should help you with the voltage part of your assessment. So you guys should have done the current questions 1 till 10. These, what I've gone through today should help you for the next few answers, okay? Yeah, so what I want you guys to do, watch the voltage video before this session. That should really give you a head start and into what I've covered. And then you can go through this session, have a go through the assessment, and make sure you do the 4 research activities there. So mechanical, chemical, heat, and light. And that will lead me into the second session, which we'll be doing next week. All right, thanks for listening, guys. Any questions, like I said, get in touch with us. Thanks.